There are anomalies associated with composition, like a lot of nickel, but very little iron in the plume of gas around it that we find only in industrial production of nickel alloys.
The shock begins the moment the new Hubble frames load onto the screens. Scientists freeze, speechless, staring at a comet performing a maneuver that should violate every rule written in celestial mechanics. The anti-tail of 3I Atlas, the structure that should point away from the sun, has flipped direction at perihelion. It doesn't bend, fade, or distort. It reverses, cleanly, sharply, almost like it received an instruction. Instead of weakening under the brutal heat and radiation of its solar pass, the anti-tail holds its shape with unnerving stability. Radiation pressure should have blasted any dust into nothing within minutes, yet the structure remains intact, bright, and unnaturally coherent. The particles inside it appear too large or too exotic to behave like ordinary comet debris, resisting forces powerful enough to tear normal matter apart. Some researchers describe it privately as the moment they realized the tail wasn't responding to sunlight, it was ignoring it. In routine comet science, strange tail angles are usually chalked up to viewing geometry, optical illusions, or perspective shifts. But this time, no one can hide behind that excuse. The numbers don't allow it. The geometry doesn't match it. The flip is real, and it is controlled by something no one understands. One veteran astronomer mutters that it feels like watching a river suddenly run uphill. The laws of physics simply don't permit the motion they're seeing. The flip occurs at the exact moment 3I Atlas hits its closest point to the sun, raising disturbing questions about timing, triggers, and whether internal mechanisms or something else are activating right at perihelion. NASA refuses to comment publicly, yet leaked internal emails show scientists describing the behavior as having mechanical-like coherence, a phrase that instantly becomes taboo inside mission channels. Loeb's models attempt to provide natural explanations: evaporating ice clusters, massive embedded fragments, unseen inertial forces. But even he admits none of them account for the perfect symmetry, the precise timing, or the counter-solar defiance of the flip. Right now, no model on Earth can explain how an anti-tail can choose when to reverse direction. And the worst part, this isn't ancient behavior frozen in the past. The flip is happening now, in real time. As 3I Atlas races toward the December 19th observation window, the moment the world must face whatever force is controlling this impossible motion. And scientists fear this flip is only the first sign, because what comes next breaks even more rules of nature. Scientists are running out of ways to stay calm. With every new data drop, another anomaly is added to the growing list, now 13, and each one pushes 3I Atlas further outside anything the scientific world has ever seen. It behaves like a comet that refuses to be a comet. Telescopes capture it brightening in sudden, irregular pulses, then dimming without warning, almost like it's signaling. Moments later, the object slows down, then speeds up, then tilts into a rotation that defies every known model of how interstellar debris should move. And through all of this chaos, there is almost no outgassing at all, no jets, no eruptions, nothing strong enough to explain the power behind these motions. Experts who once mocked the early concerns have quietly stopped giving interviews. The confidence is gone. Many avoid questions entirely, because the truth is uncomfortable. No one actually knows what Atlas is doing or why. Loeb's criticism hits harder now. How can anyone claim expertise when humanity has studied exactly 2 interstellar objects before this one? The silence from major institutions isn't caution anymore. It looks like fear. Inside research teams, the arguments are growing sharper. Some insist they must be missing a natural mechanism, something subtle and beautiful that physics has not yet revealed. Others whisper the theory no one wants to say publicly: what if they're not studying a natural process at all? What if the patterns look chaotic only because they are deliberate? Each new data set arrives like a slap to the previous one. Predictions fail almost instantly. Models break within hours. The object behaves like it is rewriting its own rules in real time. Astronomers have started calling it the rule breaker, though never in official papers, only in late-night messages and private video calls when the worry shows through. Behind those closed doors, the tension is clear. Treating 3I Atlas like a normal comet isn't science anymore. It's denial. It's the last shield protecting them from an idea too enormous to accept, and still, the object drifts closer, silent and indifferent, almost as if it knows the world is watching, almost as if it's preparing an anomaly number 14. Scientists knew something was wrong the moment the latest spectral readings came in. The anti-tail of 3I Atlas wasn't behaving like dust at all. It looked heavier, more coherent, almost as if it were made of clustered fragments that refused to scatter. In third-person silence, the research team stared at the data, each line confirming a fear none of them wanted to name. Solar radiation should have ripped micrometer particles apart and blasted them into space. Instead, the anti-tail held its shape like something designed to resist the sun. Behind closed doors, Avi Loeb outlined 3 possible models, each worse than the last. The first suggested evaporating ice fragments, but the rate of evaporation seen in the data made no sense unless something was constantly replacing them. The second model proposed large inert objects shedding from the body, but if that were true, 3I Atlas was releasing pieces far bigger than anyone expected, almost in a pattern. The third possibility was the one no one wanted to say aloud: material not influenced by known solar forces, material that behaved as if it had its own rules. None of these explanations fit perfectly. Every attempt to force the anomaly into traditional physics only widened the gap. If fragments evaporated before reaching the anti-tail flip point, then something behind the scenes was replenishing them. If the material was instead made of larger chunks, then the object wasn't shedding debris. It was deploying it. Even stranger, the anti-tail kept pointing in the same direction even as 3I Atlas rotated chaotically. It was behaving like smoke rising against a storm, impossible without an internal mechanism deciding where it should go. NASA analysts grew quiet. Their official classification quietly shifted to a new term: non-cometary debris. No one explained what that meant. No one wanted to. And now, with the December 19th observation window racing closer, the quiet question lurking beneath every meeting, every email, every sleepless night finally begins to surface: what exactly is the anti-tail made of, and who or what is controlling it? Because the next part may answer that question, or make everything far worse. Scientists didn't expect the old nightmare to return, but it has, in the form of 3I Atlas. A haunting parallel spreads through research circles. Decades ago, physicists spent $90 million chasing sterile neutrinos, invisible particles hinted at by strange, unexplained signals. Those anomalies were treated with full legitimacy, even respect. Entire labs were built around them. Entire careers rose from the belief that the universe was whispering something new. But after all the money, after all the experiments, the result was nothing. A cosmic ghost that vanished the moment we tried to grasp it. For many scientists, that failure is still a wound. And now 3I Atlas is ripping it open. Because the same pattern is repeating, but this time the stakes are incomparably higher. Despite 13 confirmed anomalies, despite behavior that violates every rule of comet physics, many senior astronomers dismiss 3Y Atlas outright. They mock the idea that anything unusual could be happening. They refuse to look at the data before forming conclusions. Some won't even read the observation logs. And Loeb is the one asking the question everyone else is afraid to say aloud. Why were phantom particles treated seriously, but an object entering our solar system is not? The answer here is terrifying. Neutrinos, even hypothetical ones, pose no danger. They could not change history. They could not switch off satellites, steer themselves, or alter their trajectory at the last minute. Pursuing them was safe for the scientific ego. But an interstellar object showing signs of non-natural behavior, that threatens everything: careers, theories, reputations, even humanity's sense of cosmic safety. In private meetings, younger researchers whisper what older scientists refuse to admit. Astronomy punishes anomalies. Particle physics embraced them. Astronomy buries them. The sterile neutrino disaster now stands like a warning sign. Ignoring anomalies doesn't make them disappear, it only delays the truth. And with 3I Atlas, the consequences of ignoring the truth could be far more dangerous than missing a new particle. This object is accelerating, dimming, brightening, flipping its anti-tail, and shedding material that does not act like dust. Something is happening right now, and nobody can stop it by pretending it isn't. That is why December 19th feels like a countdown, not just to an observation window, but to a reckoning. A reckoning scientists hoped would never come. Because what happens next may force them to confront the one possibility they fear the most. The shock begins with a single line, a sentence Avi Loeb once wrote, then removed after editorial pressure, resurfacing at the worst possible moment. It suggested that a solid object more than 10 kilometers wide might be deliberately guided into a plunging orbit around our sun. At the time, most scientists laughed it off. Now, as 3I Atlas defies physics with every new observation, nobody is laughing. Researchers compare its path against thousands of simulated trajectories, and the results are uncomfortable. Nothing in a natural interstellar reservoir behaves this way. The odds of a random rock entering this exact orbit, with this timing, this stability, and this sequence of anomalies drop to nearly zero. For the first time, teams admit quietly that the pattern looks chosen, not accidental. Loeb's once dismissed hypothesis has since passed peer review, forcing the scientific world to confront something it never wanted to face. What's worse is that nothing about 3I Atlas contradicts the technological explanation. Every anomaly lines up disturbingly well. The anti-tail flip that behaves like a controlled maneuver, the heavy non-dust material that refuses to scatter, the unpredictable rotation that somehow stabilizes instead of falling apart. The critics who used to mock the idea have grown silent. Not because they agree, but because their natural models no longer work. Every new data set breaks another rule. Every updated projection collapses another explanation. The silence is no longer academic, it's fearful. Meanwhile, letters from ordinary citizens flood observatories around the world. People with no scientific background describe a strange intuition, a feeling that this object is not wandering, but watching, not drifting, but executing something. Scientists normally ignore such instincts. This time, they don't. Because privately, many of them feel the same thing. Ravech's recent analysis deepens the dread. If ancient civilizations wanted to monitor young star systems, they could hide sensors on interstellar debris and let them drift for millions of years. No propulsion, no signal, just passive reconnaissance until something or someone triggers them. Suddenly, 3I Atlas is no longer just an object. It becomes a possibility, a probe, a courier, an investigator. Something that arrives silently, behaves strangely, and studies everything it passes. And now, it's heading toward Earth's observation window with unsettling precision. With only days left before its close pass, the technological hypothesis is no longer fringe. It is no longer theoretical. It is no longer avoidable. It is the scenario that fits too well. And the world is running out of time to decide what that means. Because what comes next may prove whether 3I Atlas is simply passing by or arriving for a reason. The tension breaks like a pressure wave across the scientific world. December 19th isn't just a date anymore. It's a deadline. Every passing hour brings 3I Atlas closer, and with each new measurement, its behavior becomes stranger, faster, more aggressive. Unlike Oumuamua or Borisov, quiet drifters compared to this, 3I Atlas behaves like something aware of being watched. Its brightness pulses in irregular, almost coded bursts. Its rotation lurches unpredictably, like a machine rebooting mid-flight. And its anti-tail, which should have dissolved weeks ago, now swings into a new formation that no model can explain. Inside observatories from Chile to Japan, astronomers move in tight, panicked rhythms. They know this is the one shot. The observation window that could redefine humanity's understanding of the universe. Some fear their telescopes won't even capture the moment if the object continues to break every predicted pattern. The slightest deviation, even a fraction of a degree, could bring 3I Atlas closer than expected, or send it slipping into the darkness before they can learn anything from it. Meanwhile, letters and emails pour into research centers, thousands of them, from amateur sky watchers, from school children, from people who cannot sleep anymore. Their messages are the same. Why does this object feel different? Why does it feel like it's coming for a reason? Awe mixes with a quiet, growing terror, as if the public can sense the scientists' unspoken fears even before they are voiced. Behind closed doors, researchers whisper what they refuse to say on camera. If the anomalies keep escalating at this rate, December 19th might deliver an answer humanity is not prepared to face. Something about the behavior, the pulse-like brightening, the shifting trajectory lines, the uncanny anti-tail symmetry suggests an intelligence, or at least an unknown force, at work. No one wants to say it. No one can unsee it. And the truth is brutal. No one can predict what will happen next. Not the veterans who track comets their whole lives. Not the theorists building emergency models at 3 a.m. Not even the instruments themselves, which now return readings labeled unclassified motion. Some fear the object will simply pass by, leaving nothing but unanswered questions. Others fear the opposite, that it will drift closer than planned, granting a view too intimate, too revealing, too dangerous. So the world waits, breath locked in its chest as the interstellar rule breaker closes in on the narrow December window. An object that does not obey physics is approaching. And whatever happens next will begin the moment this countdown ends.